appreciate everybody joining us today. A little bit about myself. I worked in aerospace for about 2 decades in aircraft engine manufacturing. I graduated mechanical engineering out of University of Montreal. Later, I got my master's in engineering, and I reside in Arizona right now, Phoenix, Arizona. In this presentation, you should expect to see an overview of mostly swept surfaces. We'll analyze a surface and repair it, and we'll get to realize shape. The surfacing is needed for consumer product aesthetic appearance, as well as highly engineered shapes, turbine blades, and exhaust manifolds, for example. Surfacing in NX is really integral to NX in the sense that you can do extrudes and revolves similar to you do solid modeling. You can get into surfacing and then back into solids and create your drawings off of surfaces. It's really integrated into NX. The user will be able to integrate this into solids and also be able to modify surfaces. It's like parametric. It allows fast surface design for industrial and concept design, and allows specific surfacing following curves for detailed design. It meets, and we want to make sure to meet all quality standards. So with that, I am going to, one more page here. Couple types that I'm going to go over is, surfaces that have one section. In the picture here, you can see there's a section. Usually there's a section and a guide in swept surfaces. There are some surfaces that are ruled surfaces. There'll be just a section. There are some that have a section and a guide. There will be some that have multiple sections and multiple guides, and that gets more and more complex. So we're going to get to, by the end of this session, we'll be redesigning this cowl area, because I don't like the way it pinches over here. But let's start by understanding some of the basic surfaces that are available in NX. So very basic surfaces you'll have right in your home and NX modeling. You can do an extrude, and if the extrude has just a curve, then that extrude by definition will be a sheet. Let me bring my dialog panel over from my other screen. It stays here. Obviously, if I put an offset on it, right, it would turn into a solid and gets a thickness. But as long as it's no offsets, it becomes a ruled surface, and that's an extrude. You can do another extrude this way in the other direction. You can pick different directions, specify the direction that you want to extrude. It's a ruled surface. So it follows the U's in one direction and only one V in the other direction. You could also do a revolution, a revolve, rather. Similarly, if the revolve is just a curve, like this one here, it could be around this vector, this point. Because this goes a 360, it could turn into a solid, but otherwise it could also be a sheet since it's a single curve. So those are very basic surfaces. I'm gonna get rid of that last one. When you want a section to follow a guide, then you have to go into more advanced surfacing. So here we have surfaces down here. This is in the solid modeling application. They brought some of the more common ones that we'll be talking about today, right here. A sweep along guide is a practical one when you have one section and one guide. So here I have my one section, middle mouse button, and I have my one guide. There's really not too many things I can do here. I can offset it, turn into a solid again. But this is not a ruled surface. It follows the guide. That section follows the guide as though that guide was just recreated perpendicular to the section was recreated perpendicular to the guide. Okay, then we're going to look at some other types of surfaces. We'll look at the surfaces that have laws, for example. Sometimes there's manifolds. You may need an area law or a scaling law, um, or maybe an angle law. In this case, we can go to a function called swept. This will also appear, by the way, in the surfacing application right here, swept. The same function. Swept gives you a lot of capability. It allows you to select as many sections as you need and up to 3 guides. If you have more than 3 guides, then you have to go into studio surfacing. In this case, I have a section and I have a guide. Right now I have it closed as a solid, but it could be a sheet. In this kind of surfacing, I have the ability to manipulate the orientation. For example, I can put an angular law. I can fix different normals or have it follow a vector or direction, force a direction. Angular law in here will allow you to have different types of laws. You can have lockers that can actually drive how this manifold opens. You can have things like, for example, a cubic law here would allow me to start at, this is fairly big area, something like 5,000 on this side. That's going to go to 0, so it's going to pinch here. That's not good. That's an angular law in degrees. My apology. Have it go from 0 to 90. All right, that's going to twist that around, or maybe 45 is enough twist. So we have the ability here to change the angle. We also have the ability to change the scaling. And this could be good also for, again, the manifold where there's an area law. This allows us to change the area to go from a value. This is where I have to put 5,000. And that area can go, right now it pinches to 0, but it can to 1. I can make it go to 10,000. This can follow an area law, an Excel spreadsheet as well of area laws. So this gives you the control with the swept function. Now we're going to get to another application of swept. So I promise I get back to the car here. We want to try this cowling on the back here. So to do that, I've created a swept law. I did miss out on something. Before I get here, I want to back up one step here. Before I get to that, I want to get to just a couple other simple examples here. I'll come back to the cowling in a minute. The one couple things that I missed here, just to make sure we're all on the same page. One other type of surface is a sweep along guide. We talked about that. This is practical in the case where you have grooves or tracks. In this case, it's just a track. And it does close up on itself. Again, you could give it offsets. This could be used for grooving. If this was open, it would close up the interior as well. So that's another type of surface that's used quite often. And another type of surface that I missed out on also was the variable swept surface. You may have a section that you need changing, so you can control the changes. So this type of surface here is a variable changing surface. Again, under here, we saw swept along guide. We touched on swept. Now we're going to see variational sweep. This also allows for changing of number of sections. In this case, you have a section that has to sit along the guide. It would be this section here. And right away, it knows its guide. And at this point, I can decide to manipulate sections. For example, I can go in here and add a new set. now I have actually 3 sets. I can move this one along to any point along the surface. What I'm doing right now is I'm introducing sections along the guide, and I'm able to manipulate for example, this 1 here can become 2, and I'm manipulating the size of that section. It's sort of on the fly creating sections. It could be right at a given point in manipulating the values. There's the 2. It's a little hard to see, but I can expand that one. It's recalculating the geometry. This is practical in situations where you have given changes at given points along a surface. And so it scales up, scales down. I can add more sections just by hitting the plus sign here, and I have another section, and then I could go again and make the changes that I need on that section. This is called a variational sweep. So I had to introduce those 2, and now I'm going to try that cowling. So in this car here, I want to replace this cowling. I have something very similar right here, just to practice on. So just to show you how that would be, I picked up another cowling area here. Looks like the front of a jet or maybe part of a car, a hood and a trunk area on a race car. I'm going to go create a swept surface through that one because I have multiple guides and multiple sections. So I have one section, my first section is this one here. I have to make sure all the sections align. I hit plus here, I get my list of sections. My second section is this one here. I add another section over here. And one more section. Yeah, that one there.
Hey, Richard, we have someone wondering which bundle this is that you're using.
Oh, good question. So yeah, a lot of the functionality does come with a Mach 1, things like the extrude and the revolve, the ruled surface and the revolve. When you get into this swept and surface variational sweep, you would need to be in a Mach 2 bundle. That's for these functions to get out of this. And it's under surfacing for these here, swept, as well as the sweep along guide that we talked about, as well as variational sweep. That comes with the freeform modeling and Mach 2 bundle or a freeform add-on. That's your minimum requirement is Mach 2 to get all the freeform. So yeah. Does that? I hope that answers the question the gentleman had or the lady, Andrea.
I think it does. Okay. And if you have further questions, just go ahead and put them into the questions box. We'll be happy to answer those.
I could get you the exact license number for that, the Siemens number. Here I'm creating guides for my surface now. So I'm going to select the edge over here and the edge. Oh, I have to make sure to press plus here. That's very important when you're selecting guides and sections to not get them mixed up. You have to select them and select the plus sign every time you add a guide or you want to change anything on one of the guides or sections, delete it or change the order of the guides. This is a surface at this point. I'm just going to OK here. And if I just left it like that, we could see that it's not too good. I could go do an analysis. I like the reflection line analysis for these kind of curved surfaces. It allows you to visualize visualize that surface and see that there's a couple of wrinkles here. You could see where the lines, the reflection, it's like holding a flashlight or or a mirror, that this would be a mirror. You could see that you wouldn't look too good if that was your face in the mirror, right? It would distort it here. So we're trying to get smoother lines. Where it breaks but still touches, it's a discontinuity in curvature. Where it breaks and doesn't touch, it's a discontinuity in tangency as well. So we're going to try to fix that. I could double click on that surface and take a look at what they have already built in here. They have some smoothing options. Right now what's happening is it's a linear interpolation between each of these sections. I can change that to a cubic interpolation. That'll make it a little smoother this way. Then here, right now it's aligned by parameter. I can do preserve shape. You could see what it's trying to do. It's doing by parameter is very, very similar, where it's grabbing different parameters and trying to map it. What might be better is arc length. See, that would actually, 10% of this arc length would go to 10% of that arc length, 10% here, and it's not going by parameter points. So that's already better. And yeah, uniform scaling. So we want to keep it that way. So I go okay here at this point, and I do my analysis again. So it looks fairly smooth everywhere except for right here. I would say there's still a problem here in my surfaces. So I have to go one step further in surfacing. There's an area here that it lets you edit surfaces. You can do matching of edges. The one I use the most is the X form. It shows you the underlying points of the surface, the poles of the surface, degrees and patches. In other words, you can change the degree and patches right here. But right now I could take a look here and see that I have some intersections that I don't like here between these two surface patches. I am
Richard?
going to, yes?
We got two questions at the same time.
Okay, yeah.
So Roger wanted to know, can you sweep the other direction, small point to larger rear point? In other words, is surface shape order dependent?
It is order dependent, but in this case, it can be done. The two end sides should not have any issues going that way. So yeah, you could do it the other way. The mid curves would remain the same, and it would work out very nicely as well. There's no, in this case, you can go both ways. I haven't tried it though, so that's something I could get back to this person. I'd like to try that actually. I haven't tried it going the other way.
Okay, Roger, I'll send you an email after the session's over.
Yeah, please send me the email. I'll try it and confirm that answer.
Okay, and the second question is from Philip. He wanted to know, can you change the arc length percentage? How? If so, how?
Yeah, so we're back here. Arc length percentage. Right now we were going by arc length. By points would be the way, which is, here there's some specific points we can grab. If there were points on the curve that could align better, we can select by points. You could see in the picture here, so you can go by points, so that will align it. But by arc length, it's really doing a percentage all the way through. I think I understand what that person wants. She wants to make this 10% equal to that 20% or something like that, so that you could skew more towards the center area and let the edge fall off more, as opposed to having it equal spacing. I don't think you can do that in the sweep function, the swept function. What I would advise is to go towards a studio surfacing, which studio surfacing gives you a little bit more controls on, you can go through many sections in many curves, and then you have control over G0, G1, and G2, and the flow directions, which actually can be a little more powerful. That's one level further in studio surfacing. However, if you want to be exact, we'll do a measurement here in a moment to see how far off from the curves I am. Swept actually hugs those curves a lot better. But yeah, you can't manipulate the arc by change the percentage on the arc length in that feature to answer the question.
Thank you.
Yeah, that was a long answer, pardon me. Yeah, so back to X-form. I will eliminate this top one here. And that's because I actually went back and forth just before I got online here and tried to eliminate the bottom one, and I realized that this gives it better. I could have done that in front of you. This one actually hugs the curves a lot better. So again, go back to the analysis, reflection, and we'll pick that and take a look. So we don't have any discontinuities. There are some minor inflections in that area, as well as in some of the other areas. What we could also see is a deviation gauge. If we do deviation gauge between the surface and the underlying objects, like I was saying, we want to hug if they were, scientifically important curves, physically important to aerodynamics or thermodynamics. You're pretty close here. This is in millimeters, so we're at like 3/300ths, 4/100ths of a millimeter. It's probably less than 1 thou in inches. So we're very close. If we wanted to go a little bit smoother, I was able to get slightly smoother on the analysis. Let me go back, Control Z to kink here. I was able to then go back in and make that again arc length. And I can go into surface X form again. And I'm just playing around with actually, I think that's as smooth as I'm going to get it at this point. I was able to, I need to go further back. Oh, completely went all the way back. My apology. I go back to here once again. Swept. I could go section 1. Good review, doing it again. Section 2. I just want to try to delete the other side. I think it would give a better result if I actually deleted the other curve and do an analysis on that. Go back to a arc length and X-form that. Actually, I already have it doing what I want right now. So I'm actually better off now. One thing I didn't do, I didn't prove out what I wanted to show, but it's okay. One thing is I wanted this interpolation to be cubic, to have something rounder. So yeah, we're within 3/10 of 1 thou. Okay, here I see again. Here's my X-form issue. Okay, I'm back to where I wanted to be. And I want to delete this bottom one this time. The other time I deleted the other one. This time I'm going to delete that one. And the reflection line analysis, that looks a lot better to me. But you're going to have to prove to the scientists that it's the deviation, I think, is a little higher. me do a deviation gauge. Doing this surface. It's going to be down here. Now we're at 0.3 millimeters deviation. Because this is the cowling, 0.3 millimeters is still quite negligible. And I would probably go with this surface here. Okay, so now I go to my car and I'm going to try the same thing. I'm going to work on this part here. I don't like how that surface comes in over here. I'm going to work on this part, find that in the navigator, make that current. So there's already a surface over there. I will not be using that one. That's the through curve. Actually, I need these also. So make that current.
Hey, Richard.
Yep.
And Brian wants to know, in the fourth section, why not have that curved part of the path curves?
This bottom curve. So this. Oh, you mean like have a curve on the top here? Yes. We could have one additional guide. I was thinking about that too. That just comes up on the top, or one additional curves on the inside here. We can add additional curves this way, or we could add additional guides that way. What we could do is try to drive the surface this direction, but that wouldn't be good because it's going around a guide that's very steep over here. It's better that the sections are steep and the guides are less curved, I should say, instead of steep. But yeah, we could add curves and we could drive it in either direction. There's some trial and error. I find that it's better to go from these high curvature sections and keep the guides as smooth as possible. I hope that answers that question. Some of these is just try a little bit of trial and error. It's good to try it out on, a simpler surface before trying it on maybe one of these. But this works very well. Even on this cowling here, I did a swept. In this case, it's important to use your design rules up here, or selection intent. On tangent curve here. So that's one of my sections. I'm going to use this as a section. And again, that same thinking is what some people are asking, is which one's a section and which one's a guide. I could run this as a section, and have those as all guides. But I go with the theory that the guides should be smoother and the sections should have the higher curvature profiles, sketches. You have to make sure the arrows are on the same side. Don't forget to press the plus sign. That's my biggest mistake, is I forget to press that plus sign. It won't work if it thinks it's the same section. Like the single curve up here. Both of those curves make up one section, and I need to flip that arrow. And then over on the guide curves, I could have one guide curve. You could see how messy that is, but I do have another guide curve up here that will straighten everything out. That curve. And I think that's similar to what somebody was asking, is could you have another curve or other points? And you can keep adding guides in this. In a swept, you can add up to 3 guides. In the studio surface, you can add, they say N guides, but I think the limit is probably like 99.
Hey, Richard, how do you change section arrows if they're the wrong way?
Yeah, there are 2 ways to do it. One way is to double click the arrow. Like here, the section arrow, if I double click this, it's going to flip that, right? That section flips around. So the direction is important here. But you could also, you could also change it up here. you could go to like section 1 or 2, let's say, and then use this arrow here. Oh, that's remove. I could do it on the guides, right with, oh, there it is, sorry, it's up here. So if I'm selecting, I escaped out of there. Let me restart it. No, I didn't keep it. Okay. So once again, you get reinforced lesson learning. Here's a way to flip. So this is one way to flip, is you just see the little pink on top, the little pink arrow, and you can double click, a quick double click there. The other way is, so I add another section here. The other way to do it is up here, this one, reverse direction. And that also reverses the direction there. And then this one, this side here, it's on that side. It's important to take your time and make sure you're doing it right. Because if you make it, you could make changes, but when you're selecting, it's still easier to get the right design intents. So they're all on the same side, and now I can go to my guides. So I started doing this, and then I don't know what I did, but I actually pressed escape instead of undo. Then I add another guide over here. So that cleans it up. And here I happen to be in the right. Usually it comes in by default as linear. Arc length comes in as parameter. So you would want to get, again, you would want to see it as an arc length in this case again, and not go. Perimeter is good if you have the same geometry that's just different sizes. But in this case, we're going towards almost a circular shape down here, from a concave to a convex. So you're better off with arc length. Keep it as a sheet. And interpolation, I wanted that to be cubic. Right. So once you have it, at this point, I can replace my old one here. I can replace with my new surface that I just created. Yeah, I need to make that current feature. I probably want to show this last game. Yeah, so that's my new surface. And if we look at it with reflection lines, yeah, it should be fairly smooth. I didn't show you the one before that, but this is the surface I'm going with. Do you know, I think I didn't plan on doing this, but I think I'm going to show you just one other type of surface that we have in NX. This is the newest style surface. If you're doing a consumer product and it's all about aesthetic, styling, industrial design, in fact, you may even be going off of a picture. And we have another type of surface called the realized shape. This allows you to do things like, let me set it up right here. Let me go back to the start of this. Okay, so we have our motors in here, and make that the current part. And I'm going to show a picture. So this is a much more organic way to do modeling. It's called realized shape. Realized shape allows you to start with a primitive shape, like a sphere or cylinder block, or even just 2D. I'm going to start with my sphere. And then from a sphere, I could start transforming this. This is much more of an industrial application to quickly get a prototype from even a picture and then send that into the detailed design. Surfaces are useful in concept design phase. So yeah, I could keep tweaking this. I could also do other things to this. I can split these faces. And keep tweaking it again. It's just a very organic way to be modeling something that would be much harder to do, just sweeping or lofting. I can also make a blunt nose, set a continuity, go sharp over here, and then keep transforming this cage. This is a fairly new organic way to be modeling, and it fully integrates with solid modeling. I could close this up into a solid. If I go further down the line, even in this example, let's go to the midpoint of this design. Which one were they working on? I think it's one of these. No, it's this one here. This one. Yep. You get to a point where you may have some surfaces defined. Again, the realized shape allows you to quickly mesh the surfaces together. Or, sewing a cage is called. Actually, there's already a cage. I want to edit that cage rather.
Hey, Richard, can you confirm is Realize, is that in Mach 3?
That's a Mach 3 application,
Okay.
real-life shape, what I'm showing right now. That's Mach 3. Thanks for the question. I should have clarified. What I just did here, I just made that curvature, tangency, continuity in one shot. It makes life very easy. Same thing here. This is about the easiest surfacing application I've ever touched. And I've been in the industry for, shouldn't say, but more than 25 years. Yeah. And this is, the simplest way to get a quick design out the door. Once I like that, go back to transform the cage. I could easily transform. Here, take a look how smooth that is. Just transform some more. I could transform just this point. Manipulating the whole surface by doing that. And this is more of an industrial design application. Doesn't work very well for doing turbine design because it has to follow the curves. In that case, I would stick to the swept applications. But for quick industrial design, this is a lot of companies are replacing their design tools. They had different industrial design tools with this realized shape. Once you're done, you can go to the next step, which is probably to continue with your surfacing operations. And this blends right into everything we were doing before. But once this is done, it would give you the finished shape. So I just had to close that up. There's still a surface that I have to work on in there. But the realized shape is really an easy surfacing tool that allows you to quickly come up with shapes like this. Whereas what we were doing before, more exact shapes, you would use a swept surfacing tool or a sweep, a long guide, or a variational sweep. Those are your main surfacing capabilities in the advanced surface area. So again,
Mhm.
notable takeaways, NX has extensive tool suite to handle all types of surfacing and repair. It's integrated with a solid modeling and part navigator, all the history, making changes, and allows fast conceptual design, like in realized shape, or precise detailed design, like in the swept function. There is Saratech offers these classes, in-depth classes in all the freeform shape design, as well as shape design with NX Fast Start for people that do solid modeling and surfacing. So we have all of those trainings available at Saratech. I
Mhm.
hope to see you guys face to face as well one day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.